Hello guys, this is Sri. So it seems like after some long time, I have the good news. Like our channel is now reached their basic level monetization, and I done the monetization, and I also enabled a few features like the join button. Few things I enabled. Maybe if you're interested, you can take a look at it. Okay. So in today's session, we are going to see the complete details about the InnoDB cluster. Okay. So this is the long-awaited topic. I also asked few of the our viewers reached to me privately and asked to publish the video for InnoDB cluster. Okay. So in this video, what we are going to cover, we will see like what is InnoDB cluster, and there is few architecture diagram from the MySQL documentation, and yeah. So after that, where I have created few servers, three. We are going to create three node InnoDB cluster, and then we will install the MySQL router, and we will see how to configure the MySQL router and how to connect the MySQL through the MySQL router. And also finally, we will see some scenarios based things like InnoDB cluster supports single primary mode and multi-primary node. We will see how to do that and how to promote the specific node as a primary and how to remove the instance, how to rejoin the instance. Okay, so we will also see some things around it. Um, and maybe this video may be a bigger one, but I feel that it will be helpful if you are learning the InnoDB cluster. As usual, it is the complete demo video we see. And maybe if you need any further topics in the InnoDB cluster, please comment. We'll try to make it on that. Okay, fine. So first is what is InnoDB cluster, right? So we aware this is the HA solution from MySQL, and this is completely fault tolerant. Okay, means it will continue operating in case any failures or malfunctioning. Okay, for example, if you have three node cluster, if one node is down, it will select the other node as a primary and it will start functioning. Okay, and you can write on a single node, or if you want to write on all the nodes in the cluster, that is also possible. It can work as a single primary mode or multi-primary mode that we can configure. Okay. Usually I recommend single primary mode until there is a strong reason to write on all the nodes. Okay. And we have three major components in this architecture. Uh, in internally, InnoDB cluster uses the group replication. Okay, MySQL group replication. Group replication provides the virtual synchronized replication. We will see that how it is working in the architecture diagram. And you can completely manage the InnoDB cluster, like adding the instance, creating the cluster, configuring the cluster. The entire things you can manage with the MySQL shell. MySQL shell is the latest uh, client tool. There it supports JavaScript, Python, and SQL. You can write scripts. Like it is the advanced MySQL client. Okay, and we have the MySQL router package as well here with the InnoDB cluster. It is used to do the load balancing. Okay. If you want to split your loads, you can use it. Okay, fine. Now let's see a brief explanation about the architecture. Okay, how the so here I am majorly focusing the architecture of group replication because InnoDB cluster internally it is using the MySQL group replication only, right? So we will see how that group replication is working, and also for the better understanding, I will also explain how the traditional async replication, what is the difference between async replication and the group replication. So for the comparison. Okay, fine. So let's go to the MySQL document page. Yeah, so if you find this link, replication technologies, so here you will see source to replica replication and group replication. Okay, I just click the first link. Here you can see the topology for the um, source to replica, that asynchronous replication. This is the asynchronous, traditional asynchronous replication. Okay, so we mostly aware how this is working, right? So asynchronous means the name itself, we have the meaning. Like if you have source and replica, you are executing one transaction on the source will execute it, source will commit it, source will return in the bin log. It will never mind about the replica, right? So that is why it is called the asynchronous. Replica can connect anytime the source, and it will read the bin log, and it will get the data from bin log, and it will apply through the SQL thread and IO thread and bin log dump thread. Okay, this is how replication, asynchronous replication is working. So here you can see the transaction is coming and it engine. During the commit, it will be written in the bin log. Okay. But if you are using the non-transactional engine, there is a, before the commit, once the bin log. Once that statement is written in the bin log, it will start functioning. Okay. That for the execution, for the transaction commit, it will never depend on the replica. Everything will happen in the source itself. Okay. It will never mind about the replica. And the replica can connect the source and it will read the bin log and it will copy the events from bin log to relay log. Then the SQL thread will be apply the statements on the replica. In that way, replica will get synced with the source. Okay. So for the transaction lifecycle, it is not dependent the replicas. That is why it is called the asynchronous. Source will process the transaction, source will execute the transaction, source will commit the transaction, source will return the bin log, transaction in the bin log. It will never mind about the replica. Whenever the replica need the data, it will connect the source, it will read the data from bin log and it will copy to the relay log, then it will apply the transaction from the relay log. That's it. Okay, so this is the how traditional asynchronous replication works. Now, let's see about the group replication. So here in this same link, I will add this link in the description. And better you can also find it. Replication technologies, just type, it will come in the first link. And if you click this group replication, then this page will open. So here I would recommend to read these paragraphs. That is very informative. You will get to know how exactly the group replication is working. And I will also try to explain. Okay. So let's consider 3-node group replication cluster. Okay. So here node 1, node 2, node 3. Okay. Here member 1, member 2, member 3. So here, let's say the node 1, the member 1 is receiving the transaction. So what happened here? The member 1 will execute the, let's say it is receiving the update statement. Okay, to execute, it is updating, it is running that update and it will not commit the transaction. Okay, so before committing the transaction, here there is a process for certification. Okay, this is the new process. Here, comparing to the asynchronous, here we have the certification process. So the main purpose of the certification is conflict detection. Okay, so let's say you are receiving one update statement here for the same row, the same time, member 3 also receiving the same update statement and it is also executing the query and member 1 is also executing the query. Then what happened? It will conflict, right? It will conflict. It will create the failures, right? So to avoid this, the group replication, it introduced the certification process. Okay, it will receive the query and it will execute and it prepare the write sets. Okay, write sets means it consider, it have the, let's say if I modify one row, then that one row and the unique identifier of the row, maybe it is the primary key and the modified data and database name and the table name and the global identifier ID. I mean the GTID, exact position. So this all will be available in the right set, and this right set will be published to the group. Okay, published to the group, and the member 2 and member 3 both will certify, hey, you received this update and you send the right set for the certification. Member 2 will give the acknowledgement like, I did not receive this. Member 3 will give the acknowledgement, I did not receive this. So that transaction is certified. That is good to proceed. There is no conflict. Once, so this is how certification works. Once the other two nodes, I mean, other nodes available in the group or certified the transaction, then only it will commit and it will return in the bin log. And the same way for the other nodes, it comes to the relay log and it will be applied in the from the applier queue. It will apply the transaction. Then this is how it is working. So the things are same, but here we have the certification, group replication. To avoid the conflict, it has to that each transaction should be certified from the other members uh, before commit to avoid the conflict. Okay. Then the other scenario, let's consider one scenario. The same transaction member 3 also received, and member 1 and member 3 both published the right sets for the certification. In that case, what happened? Which one is come in the first order, that will win the I mean, let's say if the member 1 uh, right set is come in the first order, that will uh, I mean, that will pass, I mean, win the certification, and the right set from the member 3 will be rolled back. Okay. So maybe my explanation, maybe you get some idea, but I would strongly recommend to read these paragraphs. There are five paragraphs. Just read it. You will get a better idea about this architecture. And maybe if you have any questions on this, please publish in the comment section or directly reach me. I will also try to explain the things. Okay, fine. So this is the difference between asynchronous replication and the group replication. Okay, and you don't need to confuse, like we are seeing about InnoDB cluster, but I'm just explaining the architecture of group replication. Don't need to confuse because internally InnoDB cluster uses the group replication. Okay, fine. Now, let's come to the configuration. So in this section, we are going to see in the demo. Okay. So I have three nodes. Sorry, I have created four nodes. First one is InnoDB 1 and InnoDB 2, InnoDB 3, and router. Okay. So for all this, I have created the so host name. This is InnoDB 1. And here it is InnoDB 2. This is InnoDB 3. This is, and I'm just giving the MySQL community server, download MySQL community server. And I'm choosing the latest 8.0 version. My OS is Ubuntu. Okay. And yeah, so better I am downloading the repository. Download Ubuntu repository. And I'm right click, copy link address, and coming back to the terminal. And I'm just downloading the repository. So here you can see it is downloaded. Now I am installing the package what we downloaded. dpkg-i, giving OK, copying the same command. So you can see the package is installed. I'm executing on other nodes as well. So after this, I have to install MySQL Server and MySQL Shell and MySQL Router. Okay, so let me update the repository. Update, update on all four nodes. I'm just executing the apt-get update. Fine. So this is now done. Then what I'm doing, apt search MySQL community server. So I'm just trying to find the package. It is available. Version is 8.0.35. And apt search MySQL shell. So MySQL shell is also available. And the next one is MySQL router. Here you can see the MySQL router 8.0.35 package is also available. So once I install the repository, I can see all these packages are now available. Now, then I need to install now. apt-get install MySQL community server and MySQL shell. So I'm just installing these two packages on all the DB. MySQL router itself, we are going to connect the servers. So shell on all the DB. And this is the thing for the password. And here also password. And the third node also password. Yeah. And after we configure the InnoDB cluster, then we will come to this router node and we will install the router and we will configure it. Okay. So first let's try to complete the InnoDB cluster on the three nodes, InnoDB 1, InnoDB 2, and InnoDB 3. So currently MySQL server and MySQL shell both are getting installed. So let's wait for it. Once it is installed, then we will work on the configuration. Okay. Yeah, so here one more thing I would like to show you. You can also go with the IPs, but I feel like this is better for manageability. I am setting up the domain name resolve. Okay, inside the file /etc hosts. Okay, so I will show you once it is, yeah, it is completed. So if you check here, my host name is InnoDB1. And here you can see this is my InnoDB1 IP, 2 IP, 3 IP, and this is router IP. And I'm just giving the naming InnoDB1 for those IPs in the etc course. So I'm just resolving the host. So for example, I'm giving telnet InnoDB2 33 maybe 22 just for the check. Here you can see connected. Okay, so just for as I'm configuring the cluster, instead of IP, if I have this host names, I can easily identify it. Okay, this is the first node, second node. So for that purpose, I am just using the /etc host. I mean resolving the host names. If you want, you can add this. Otherwise, you can also go with the IPs if you what you prefer. That up to you. Okay. So now MySQL is installed on all these nodes, right? MySQL is installed. And yeah, password is 3. I can see MySQL is installed. Now, let me verify the MySQL shell. MySQL shell is installed. You can connect the MySQL shell using MySQL sh command line. Okay. And here you can see the JS means JavaScript, and you can switch to SQL mode. And here you can see execute the SQL queries. So currently I did not connect the MySQL host yet. I just logged in the MySQL shell. So it is not displaying anything. And there is the another interface which is Python. Okay, Python module also. There you can write or execute the Python scripts as well. Okay. Now let me switch to JS JavaScript mode. And now let me connect the host. Okay. So for example, you can use connect root at local host. Once I am giving this, it is asking the password, and yes. So now I connected the local host. Okay. Similarly, if you want to connect the remote host, that will also work. So now let me switch to SQL mode and show schemas. I can see the databases, right? So yeah, just you might have heard, but yeah, I'm just telling like this. You can also execute in this way. Okay, fine. So let me connect the MySQL shell on all the 3 nodes. MySQL sh, and the same way connect root at local host, and the password is 3. Yes. Here also connected, and the third node MySQL sh, and connect root at local host, and giving password 3. Yes, I just connected. Okay. So there are set of requirements to configure the InnoDB cluster. Okay. So I mean, all the nodes should have the unique server ID. Node should have the GTAD and GTAD related parameters. There are few things. Okay. And also, apart from this, there are some limitations and requirements for InnoDB cluster. I would recommend to read it from the MySQL documentation. For example, it is recommended to have the primary key for all the tables. Okay, and all the table engine should be transactional. So there are few limitations and requirements. We have the dedicated page in the MySQL documentation itself. I would recommend to read that. Okay, so fine. So what we do now, in the 3 nodes, I just connected the MySQL shell and I connected the local MySQL server. Okay. Now, what I have to do is, 1 second. Sorry for the interruption. My baby was crying. Okay, fine. So here, yeah, so where we did, yes, fine. So we just connected the MySQL shell, and we use the /connect root localhost to connect the local MySQL server as well. So now, as I told, for the InnoDB cluster, there are few requirements. The node should be configured with the GTID mode uh, and the unique server IDs. There are few things. Okay. So to check that, we have the command dba dot. Okay. So if you give this here, you can use this function configure local instance. Okay. And if you execute this, it will take you forward. Okay. It will ask one by one, and whether you need to see the node is satisfied for all the requirements or not. Okay. So here you can see the instance report, the own address, InnoDB 1. And the port is the default one, 3306 port. And here you can see user root can only connect from localhost. Okay. New account with proper source address specification to allow remote connection from all instances must be created to manage the cluster. Because currently we connected with root user, right? We connected with root user. Then that also have the access only for local host. To create the cluster, I mean, it has to communicate with the other nodes as well in the group. So the root user cannot be used here. Okay. So here we need to create the dedicated MySQL user for the InnoDB cluster. Okay. And once you execute this dba.configure will ask your run. So usually I prefer to use it, and that is recommended too. So just choose two and enter. And here you can give the account name. Any name. I'm just giving IC, and password. Just choose the strong password. Okay. I'm just giving the IC here for my simplicity, but have the strong password. Okay. So the account is created. The next step is it is asking apply worker threads will set to the default value of 4. And then you can see some configuration options needs to be fixed. These are required for to configure the InnoDB cluster. Okay, record value here it is right set, and GTAD related parameters should be turned on. Okay, and the server ID should be unique ID. Okay, and here it will ask you, do you want to perform the required configuration changes? Yes, I'm just giving Y. So here you can see I'm just giving Y and then enter. Okay, then it will ask, do you want to restart the instance after configuration? Yes. Okay. So I'm just giving Y again. And here you can see configuring the instance. The user is created. I see at the with the open host that was successfully created, and configuring the instance. And here you can see restarting the MySQL services restarted. And here you can see the status uptime, which is 16 seconds. Recently, MySQL is restarted. Okay. And here you can also check these parameters. The value should be changed. For example, select GTID mode server ID. Here you can see now GTID mode is turned on and the server ID is set, and the binlog transaction dependency tracking is changed to right set. Okay. And you may have like the question whether it is changed globally or why restart and where these configurations are getting stored, right? So here, for example, where lib MySQL, and if you check the data directory, there is the MySQL d auto.cnf. So once we allow yes for this configuration, this configurations are updated here. Okay, the static variable, all the variables are updated here. GTID mode value is on, and the server ID value is set. So whenever the restart happens, the new values will be picked up from here. So this is like the set persist configuration. Fine. So you don't need to worry about it. Fine. So now we prepared only the node 1, right? Only the node 1. Similar way, I have to prepare the other two nodes as well. Then only I can add the instances, right? So all the nodes should be capable to configure the InnoDB cluster. So I'm just executing the same command here, and I'm choosing the option 2, and it is recommended to have the same user, same password across the nodes. Okay. So I'm choosing the same name and the same password, and it is asking to update those configurations. Yes, restart, yes. And the second node is done. And coming back to the third node, same command, dba configuration, configure local instance I am executing, and I'm choosing 2, and account name is IC, and password is IC, confirm password, and yes, yes. So this is also now restarted. Now we just prepared all the three nodes to configure the InnoDB cluster. And you can also verify this by executing check dba dot check instance configuration command. So once I executed this, I have the error while reading MySQL to use the InnoDB cluster. Does not allow remote connection. Yeah, right. So before that, here I am still in the root user, right? We created the new account for the InnoDB cluster, right? So let me switch to that. Connect IC at localhost and the password IC yes, right? And now let me execute this command. Yeah, so here you can see the instance InnoDB 3306 is valid to be used in the InnoDB cluster and the status is okay. Okay, and I'm just copying this command and I'm checking the other two nodes as well. And InnoDB cluster user that we created in the previous command, right? And executing the command. Here also you can see InnoDB2 is valid to used in the InnoDB cluster. The same way I am executing here connect IC at local host. Sorry, IC yes and checking. And here also status shell connected the root user. Then we prepared the instance during connected with that, and also we verified it whether the instance is okay to configure the InnoDB cluster with this. So the next step is we need to create the cluster. Okay, so for that, InnoDB create cluster. Okay, so here we need to provide the cluster name. I'm just providing three blocks. Okay, so checking the connectivity, adding the seed instance. So here you can see validating the instance that is done. And this is the address for the instance. And this is suitable to configure the InnoDB cluster and adding the new instance cluster created successfully. And at least that is recommended, at least for the three nodes for the cluster is recommended. And finally, you can see cluster three blocks is created. Okay. So you can also check dot get. So I'm just assigning this to help. So now I can use the help dot status. Okay. So here, so I just did nothing. Like I'm just assigning the cluster name in the variable. Variable is help. Now I execute all the commands using this help. Like which variable you are name. You can use any name. This is like a variable. Okay. And now the cluster name is vlogs and currently the node address is InnoDB1. Okay. So I just created the cluster on the first node. So in the status, I can see only one node is currently available. The next step is I need to add the other nodes to the cluster. Three blocks. Three blocks is the cluster name. And in this cluster, I just prepared dot add instance IC at InnoDB2. I'm adding the InnoDB2 first. Okay. So when you are adding the node, there may be more data, right? Or maybe the less data. So when the node is getting added to the cluster, it is recommended and it should have the same data across all the nodes, right? To, I mean, to maintain the consistency, right? So when you are adding the node, it will ask like you can read this, like the incrementals, InnoDB2 has not been pre-provisioned. GTID set is empty. The shell is unable to decide whether incremental state recovery can be correctly provisioned. Okay, so this is not of the cluster, not part of the cluster before. We are just adding the fresh node. So, and the GTID mode is also empty. So it is telling like incremental may not possible here. Like, so I'm just choosing the clone option. Clone option means we are aware of the clone plugin, right? Clone backup. It will clone the data from InnoDB1 to InnoDB2. So in that case, whatever data I have from InnoDB1, that will also available in InnoDB2, and it will prepare the instance. Then it will join the cluster, right? So to choose, so you have two options. One is incremental and the clone. Increment, as I told, incremental is here not possible because the node is not part of the cluster before. In case if a node is a part of the cluster and it was leaving for some reason, or maybe you take down for some maintenance work and you are adding back to the cluster, in that case, incremental would be the preferred one. Okay. But here we are just adding the fresh node to the cluster. So clone is the preferred option here. So I'm just choosing the cap C and enter. Okay. So here you can see now the clone is happening. Here you can see file copy, page copy, redo copy, and the clone is completed and waiting for the server restart. And at the end, the node 2 will be added to the cluster. Okay, so yeah, here you can see it is ready. InnoDB2 has reached much of data transferred from InnoDB1 to InnoDB2, and the recovery is also finished. The instance added to the cluster. Okay, now you can check health.status. Okay, and here this is the primary role and it is the secondary role. And here the mode is also read only and the primary have the read write. By default, it will choose only one write, which writer, which means the single primary mode. Okay, you can also check like super read only. Okay, so I'm doing this on the node 1. Okay, but if you execute the same command in the node 2, here you can see super read only mode is enabled, right? So which means you cannot write anything in the second node and the mode is also read only. Fine. At InnoDB3, IC means that user, okay, what user we created for the InnoDB cluster, that dedicated user. Add instance IC at InnoDB3. The same thing, I am choosing clone option. Cloning is happening and at the end, the node will be added to the cluster. Okay. Yeah, the same thing. Data is cloned from InnoDB1 to InnoDB3 and restarted everything at the end. Node InnoDB3 was successfully added to the cluster. And you can also verify it by executing the head.status. Now you can see InnoDB1, which is the primary, and InnoDB2, which is the second we have here. Okay, fine. So we were able to construct the cluster. Now let me see something on switching to SQL mode. And here you can see there is one new database created, which is MySQL InnoDB Cluster metadata. Okay, so inside that, you can see some tables which having the details about your InnoDB cluster. Okay, each table have their own purpose. You can, I mean, you can view those tables and you can understand them. Okay, and also inside the performance schema, show tables. Here also you can get some details about the group replication, like for example, replication group members. Select star from, yeah, so executing this table. Also, you can check some status. Let me more clear here. Channel name, member ID. Yeah, so here also you can check the node status. Like this is the member host, InnoDB 123, and the status of the members. Online. Member role is primary, secondary. So if you are running group replication cluster instead of InnoDB cluster, I mean, without MySQL shell and MySQL router, if you are just running the group replication cluster, then you will use this table mostly to check the status of your group replication nodes. Okay, but as we have um, MySQL shell, like InnoDB cluster, we are using this like help dot status command. Here also you can verify the status. And if you are inside the MySQL client, then I'm just telling you can also check the performance schema dot replication underscore group underscore members table. There also you can find the status of your nodes. Okay, fine. So now we are done with the InnoDB cluster configuration. Okay. The next thing is, so currently we deal with the group replication as well as MySQL shell. We did not come to the MySQL router part yet, right? So yeah, just we created the cluster now. Now the next step is we will see how to install the MySQL router and how to configure it. Okay. So I am using the other node, which is the fourth node, router node. Here I am searching router. It is packages available. We already installed the repository here and apt get install MySQL router. It is getting installed now. Let it install. So once it is installed, we will need to bootstrap and at the end it will create the different ports for the read connection and read write connection, and we will also see how to connect through the MySQL router. Uh, and yeah, let it complete the installation. Yeah, so installation is completed now, and you can see the MySQL router is, I mean, the command line is now available. Fine. The next thing is, I have to create the dedicated folder, creating the dedicated folder to store the router data. For example, I'm just giving data here. That's it. Okay. So CD data. So here I am going to store the my configuration, router related configuration. So let me come to here, have the command. Yeah. So I need to bootstrap and IC is the username, that is fine. And InnoDB one, that is fine. And yeah, directory here, root/root/data, and I'm running the MySQL router with the root user. So let me execute this and we'll see invalid argument. Okay, let me type bootstrap IC at InnoDB1. Actually, there is some encoding issue, I think, while copy paste. So let me type because I had the same problem before. User equal to root. Yeah, and now let me. Oh, oh, actually, now there is a typo. Yeah, password for IC is IC. And here you can see I am getting error. Cannot set ownership of file root data. Okay. But I am running in the root user only. Yeah, I think this is the app former issue. Let me check. etc app former dot t. Yeah, user bin MySQL router. Fine. Let me add this directory here. Well, hello directory for MySQL InnoDB cluster. Adding read write and read write. Yeah, I think that we created a new directory, right? That is not whitelisted in the AppArmor profile. So I think that would be the reason for the permission denied issue. Now I just whitelisted in the AppArmor profile. Now let me see systemctl um, reload AppArmor. Yeah, reload and systemctl restart MySQL router. Yeah, now let me execute the command and the password is IC. Yeah, pretty cool. So it is working now. So the problem is app or the new directory I created, right, which is not allowed in the AppArmor. So I just whitelisted that in the AppArmor profile. So after that, I am able to execute the command, the bootstrap command. Now let me see inside the data. You can see some files are created. So this is the router config and router data log. You will see all these files. And here you can see you can use this port 6446 as a read write port and 6447 as a read only port. Okay, for X protocol, you can use 6448 as a read write port and 6449 as a read only port. So we mostly use this one, which means if I want to write something and write plus read something, I need to use 6446 port. If I'm doing only the reads from the from some user, some they are just doing the reads for all the read connections, you can use the 6447 port, which means it will connect the secondary nodes. That is a matter here. It will just connect the secondary nodes and execute the select queries there. And if you want to do some writes, then you need to use this port, which means it will connect the primary node and it will execute the write statements. Got it? So in that way, you can split the load by using the different ports. Okay, so let's do some experiments. Yeah, before that, let me make sure that ports are listened. Okay, apt get net hyphen tools. So usually I use netstat command to check the ports. Netstat. Okay, so the ports are not listened yet, right? So the reason is we need to start. So there is a script start.sh inside the slash root slash data folder. So once you bootstrap the node, you will get this script start.sh script. So just execute it. Okay. So now let me verify. Yeah. So here you can see the MySQL is now listening this ports. right? MySQL router is now listening this ports. Fine. So ports are listened now, and we bootstrapped and we created the MySQL router. The next step is let me create one application user. Okay, so that we can verify, right? So let me quickly create user by grant all on. Yeah, access to name. Okay, so we connected with the IC user, right? I mean the InnoDB cluster user, right? So we don't have the access. Fine. Let me connect here and copy this flush privileges. Done. Now let me come to the router node, and we know the user, I mean 6446 is for the read write purpose, right? Read write purpose, and 6447 is for the read only purpose, right? Read only purpose. Now let's try MySQL. Okay, so apt get install MySQL client. So I need to install the client, right? So that I can try to check it. I'm just installing the MySQL client on the router node. Yeah, it is done. And now MySQL -h 0.0.1, and the port is 6446, 6446, right? And user is app we created. Password is app at 321, right? Yeah, I'm able to log in and select at that host name. It is connected to the InnoDB 1 and create database 3. I am able to do that. Okay. Now let me connect with the 6447 port, which is the read-only port, right? And select at that host name. You can see this is now connected with the InnoDB 2 because I'm going to I'm using 6447 port, which is the read-only port. And the read-only port means for that it will use the secondary nodes, not primary. It will execute the selects on the secondary nodes. So it choose the InnoDB2 here. And if I create any database, 3.1, it will deny it because the server is running with the super read-only mode. So here I can just execute the select statements. For example, user comma host from MySQL.user. So in the similar way, I can execute some select statements. So in case if I want to only run the selects, then I can use the 6447 port. And if I want to execute the write statements, then I need to use the 6446 ports. There are also few things we can do with the MySQL router that maybe if you have some specific topics you want to learn from MySQL router, please post the comment. We will see that. This is the basic, like how to install and how to bootstrap and how we can get connect with the InnoDB cluster. Fine. So now we see from start, we see about the architecture and we install the MySQL shell, MySQL router. We created the cluster, right? And what else? Yeah, we configured the MySQL router and we also try to make some connections through the MySQL router. Now, coming back, um, we can do few things with InnoDB cluster, like as I told. Yeah, let me show here. As you see here, now the topology is single primary. And here you can see we have only one primary node and other two nodes are secondary nodes, right? So in this case, if you want to write all the three nodes, you want to nodes as a primary, then that is also possible. Let me find it. Switch to, yeah, switch to multiple primary mode. And let me execute this. Here you can see InnoDB1 is remains primary, and InnoDB2 was switched from secondary to primary. InnoDB3 was switched from secondary to primary. And you can see the status now. Now all the nodes are primary and all the nodes are read write, right? So in this way, you can, if you want to write on all the three nodes, you can switch using the command. But usually I do not prefer write on all the nodes. And if you have any strong reason to do that, you can go with that. Like topology mode is also now changed to multi-primary, right? And switching back to the single primary, you need to use switch to single primary mode again. Okay. In that case, you can see InnoDB1 remains primary and InnoDB2 is switched from primary to secondary, and InnoDB3 is also switched from primary to secondary. Fine. Now, yeah, let me check the status. Here you can see currently the InnoDB1 is the primary. For some reason, you want to take down the InnoDB1 for some maintenance work and you want to promote the other node as a primary. Maybe you want to promote the InnoDB2 as a primary. That is also possible. You can manually do with set primary instance. Here you need to give InnoDB2, and here you can see now InnoDB3 remains secondary, InnoDB1 was switched from primary to secondary, and InnoDB2 was switched from secondary to primary. And you can also check the status. Now InnoDB2 is the primary node and enabled with the read-write mode, and InnoDB1 is read-only mode secondary, and InnoDB3 is secondary read-only mode. Okay. And if you want to remove the instance from the cluster, that is also possible. Like help dot, I think remove. Yeah, remove instance. Let's say if I want to remove instance InnoDB3 from the cluster group, I am using the remove instance of and the cluster name. Here you can see the instance InnoDB3 was successfully removed from the cluster. And there is also, you can rejoin it. There are also some useful comments we have. Yeah, but if you want to learn something specific, please let me know in the comment section. We will definitely do the video about it. Okay. Yeah, so actually, I think the video is quite long, but yeah, I think this is useful. If you have any questions, please reach me in the comment section or directly. If you did not subscribe my channel yet, please do that. And maybe who is learning MySQL, please share the videos with them as well. Yeah, I have added few things in the channel like join button and what else? Yeah, I did few things. You can take a look at it if needed. Yeah, and if you recommend some topics, please do that. I'm happy to do videos on that. And yeah, thank you. See you. Bye.